Hello students. Now our next numerical which is based on velocity time graph. Now in this numerical figure shows velocity time graph for the motion of an object. Now in this graph it represents the motion of an object on which along x-axis I have mentioned the time in second, and along y-axis I have mentioned velocity meter per second. Velocity is in meter per second. Compute the acceleration for each phase of motion. So our first step, we want to find the acceleration for the phase, means from O to A to B, and then from B to D, and then D to E, and last E to F. And second, describe how the object moves during the last time segment. We have to find the velocity of the object in the last segment of time, means from E to F, this segment. Now in Punjabi, ਸਾਡੇ ਕੋਲੇ ਆ ਗ੍ਰਾਫ ਹੈ, ਗ੍ਰਾਫ ਕਿਸ ਦਾ ਇੱਕ ਆਬਜੈਕਟ ਦਾ ਜਿਹੜਾ ਮੋਸ਼ਨ ਦੇ ਵਿੱਚ ਹੈ। ਅਸੀਂ ਅਲੱਗ-ਅਲੱਗ ਫੇਜ਼ ਦੇ ਵਿੱਚ ਕੀ ਆ ਐਕਸਲਰੇਸ਼ਨ ਫਾਈਂਡ ਕਰਨੀ ਹੈ। ਐਕਸਲਰੇਸ਼ਨ ਕਿੱਥੋਂ O to A, ਫਿਰ A to B, ਉਸ ਤੋਂ ਬਾਅਦ B to D, ਫਿਰ D to E ਐਂਡ ਲਾਸਟ E to F। ਇਹਨਾਂ ਹਿੱਸਿਆਂ ਦੇ ਵਿੱਚ ਫੇਜ਼ ਦੇ ਵਿੱਚ ਅਸੀਂ ਕੀ ਹੈ ਐਕਸਲਰੇਸ਼ਨ ਫਾਈਂਡ ਕਰਨੀ ਹੈ। ਦੂਸਰਾ, ਸਾਨੂੰ ਇਸ ਗ੍ਰਾਫ ਦੇ ਦੁਆਰਾ ਪੁੱਛਿਆ ਗਿਆ ਹੈ ਕਿ ਜਿਹੜਾ ਆਬਜੈਕਟ ਆ ਲਾਸਟ ਸੈਗਮੈਂਟ E to F ਜਦੋਂ ਗਿਆ ਤਾਂ ਉਸ ਦੀ ਵੈਲੋਸਿਟੀ ਕਿੰਨੀ ਸੀ, ਉਹਦੇ ਮੋਸ਼ਨ ਨੂੰ ਅਸੀਂ ਕੀ ਆ ਵਰਣਨ ਕਰਨਾ ਹੈ। ਸੋ ਫਸਟ ਆਫ ਆਲ we will be calculate the acceleration for the phase O to A. Now students, for the phase of motion depicted by OA, ਸਾਨੂੰ ਗ੍ਰਾਫ ਕੀ ਵਰਣਨ ਕਰ ਰਿਹਾ ਹੈ O to A, O to A, this path O to A. Now what is a change in velocity? Velocity is mentioned by the y-axis. So from O to A there is no change in velocity of the object. Means from the time 0 to 1 second there is no change in velocity. So from the help of graph, change in velocity, that is 0, and time taken by the object to cover that distance, that is 1 second. Change in time, that is 1 second. Now we know very well what is acceleration, the rate of change of velocity with respect to time. So therefore acceleration A for the phase OA, that is delta V over delta T, Now delta V, that is 0, and time is 1 second. 0 over 1, that is 0. So acceleration for the phase OA is 0. ਪਹਿਲੇ ਸਟੈਪ ਦੇ ਵਿੱਚ ਅਸੀਂ ਕੀ ਦੇਖਿਆ ਹੈ, ਜਿਹੜਾ ਫੇਜ਼ O2A ਆ ਇਹਦੇ ਵਿੱਚ ਵੈਲੋਸਿਟੀ ਸਾਡੀ ਚੇਂਜ ਨਹੀਂ ਹੋਈ, ਸਮਾਂ ਕਿੰਨਾ ਸੀ 1 ਸੈਕਿੰਡ। ਐਕਸਲਰੇਸ਼ਨ ਕੀ ਹੁੰਦੀ ਆ, ਚੇਂਜ ਇਨ ਵੈਲੋਸਿਟੀ ਓਵਰ ਚੇਂਜ ਇਨ ਟਾਈਮ, rate of change of velocity with respect to time. So 0 over 1 equal to 0. So for the phase O2A, acceleration is 0. Now students, we will be discuss for the phase A to B what is our acceleration. Now from A to B, change in velocity, that is from here 0 to 8, 0 to 8 meter per second. We will be calculate it. And from A to B, what is the time? I have marked it by dotted line and it meet at 3 seconds. Now students, we will be discuss what is the acceleration from phase A to B. Now students, we will be discuss the acceleration for the phase of motion depicted by AB segment during A to B. Now first of all, we will be find change in velocity and the point B at a time of 3 seconds. I have shown by dotted line. Now change in velocity, final velocity minus initial velocity. That means final velocity here, that is 8 meter per second, minus initial velocity, that is here 0. So 8 minus 0, 8 meter per second change in velocity during the phase A to B. Again, time taken, delta T equal to, now when the object at point B, that is time is 3 seconds, and when the object at the starting position means at A, that is time was 1 second. So change in time, that is 3 minus 1 equal to 2 seconds. Now the accelerations, change in velocity, that is 8 meter per second, and change in time, that is 2 seconds. So our answer is 4 meter per second square acceleration during the phase A B. Now similarly, using this method, we will be depict using the same steps, we will be find the acceleration from B to D. We have completed two steps from O to A and A to B. Now we are calculating the acceleration from B to D. Now students, for the phase of motion depicted by BD, now we are calculating the acceleration for the phase B to D. So adopting the same method, first of all we will find what is the change in velocity. Change in velocity, that is delta V. How can we find a change in velocity? Here at point D, velocity equal to negative 12. So final velocity minus initial velocity means plus 8. So here change in velocity, final velocity, that is minus 12 meter per second, minus initial velocity, that is positive 8, and it becomes negative 20 meter per second. Minus 12 minus 8 equal to minus 20 meter per second. Change in velocity during the phase B to D. Similarly, we will be find a change in time. Now at the point D, the time is 8 seconds, and at the point B, time is a 3 seconds. So time taken during the phase B to D, that is 8 minus 3 equal to 5 seconds. Now what is the acceleration? Delta V, that is minus 20 meter per second, and change in time, that is 5 seconds. So cancel 20 by 5, that is 4. Now the acceleration minus 4 meter per second square during the phase B to D. D ਪੁਆਇੰਟ ਦੇ ਉੱਪਰ ਸਮਾਂ 8 ਸੈਕਿੰਡ ਸੀ। ਅਗਰ ਅਸੀਂ ਵੈਲੋਸਿਟੀ ਦੀ ਗੱਲ ਕਰੀਏ ਤਾਂ ਨੈਗੇਟਿਵ ਸੀ। ਕਿੰਨੀ ਸੀ? -12 ਮੀਟਰ ਪਰ ਸੈਕਿੰਡ। B ਪੁਆਇੰਟ ਦੇ ਉੱਪਰ ਸਮਾਂ 3 ਸੈਕਿੰਡ ਸੀ ਐਂਡ ਵੈਲੋਸਿਟੀ ਕਿੰਨੀ ਸੀ? 8 ਮੀਟਰ ਪਰ ਸੈਕਿੰਡ। ਅਸੀਂ ਚੇਂਜ ਫਾਈਂਡ ਕਰ ਲਈਏ। ਕਿੰਨੀ ਚੇਂਜ ਹੋਈ? ਫਾਈਨਲ -12 initially plus 8, so -12 minus 8, ਇਹ ਆ ਗਈ ਸਾਡੇ ਕੋਲ -20 ਮੀਟਰ ਪਰ ਸੈਕਿੰਡ। ਸਮਾਂ, ਸੋ ਐਟ ਪੁਆਇੰਟ D ਤੇ ਸਮਾਂ ਕਿੰਨਾ ਸੀ? 8 ਸੈਕਿੰਡ, ਤੇ B ਪੁਆਇੰਟ ਦੇ ਉੱਪਰ ਕਿੰਨਾ ਸੀ? 3 ਸੈਕਿੰਡ। ਚੇਂਜ ਅਸੀਂ ਕਰ ਲਿਆ, ਦੈਟ ਇਜ਼ 5 ਸੈਕਿੰਡ। 8 minus 3, ਇੱਥੋਂ ਅਸੀਂ ਐਕਸਲਰੇਸ਼ਨ ਫਾਈਂਡ ਕਰ ਲਈ, ਦੈਟ ਇਜ਼ -4 ਮੀਟਰ ਪਰ ਸੈਕਿੰਡ ਸਕੁਅਰ। Now students, in the next step we will be find the acceleration from D to E. Now students, we are calculating the acceleration for the phase of motion depicted by D to E. Now you have to be look carefully at point D, that is the initial velocity, and point E, that is a final velocity. At point D, you know velocity is -12 meter per second, and at point E velocity is -4 meter per second. So first of all we will be find the change in velocity, and you look carefully from phase D to E, time is 9 minus 8, that is a 1 second. So change in velocity, that is a final velocity, -4 meter per second minus initial velocity -12. So I am writing here in the bracket, because when we open the bracket, negative, positive. So you doing this numerical must be emphasized on this point. Now it becomes -4 plus 12 8 meter per second. Now the change in time, 9 minus 8, that is 1 second. So the acceleration, that is 8 meter per second, change in velocity over change in time, that is 1 second, and our answer is 8 meter per second square, the acceleration during the phase D to E. Now, in the last step, we will be discuss the acceleration for the last segment, means for the phase E to F. So, students, in the last step of this numerical, now from E to F, we want to find the acceleration. Now, observe carefully from E to F. There is no change in the velocity. Velocity at point E, that is a negative 4 meter per second, and this line is parallel to the x-axis. That means there is no change in velocity at point F. It is also negative 4 meter per second. So change in velocity, that is 0. And time taken, now we will be calculate the time taken, that is at point F, 11 minus E, that is 9. 11 minus 9, that is 2 seconds. So what is the acceleration during the phase E to F? That is change in velocity 0, time taken 2 seconds, 0 meter per second square, means 0. Acceleration during the phase E to F is 0. Now this is all about the step A. Compute the acceleration for each of phase of motion. We have calculated the acceleration during the phase O to A, then A to B, then again B to D, and after that D to E, and lastly E to F we have calculated. Now describe how the object moves during the last time segment. So from the graph, students, there is no change in velocity. So object moves with a velocity of negative 4 meter per second. The velocity of the object during the segment E to F. During the segment E to F, in the last segment, the object moves with the velocity of negative 4 meter per second, and the acceleration in this case is 0. So I hope you understand all about this graph. If you have any problems, any questions, you can ask me in the comment box.